Hello everyone, welcome back to arpitastechcorner. So, in my previous data architecture understanding videos, you understand um, about these different type of data components of this lakehouse architecture. Now, in this video, we are going to understand how to choose the best compute engine setup for your lakehouse architecture. So, as a data architect, it is very essential. You need to understand this where all the data are stored, organized, managed to be very easily accessible format. So, in this presentation, I will explain to you how to choose the best compute setup for your lakehouse architecture. First of all, in a lakehouse, the compute engine is responsible for all activities like data ingestion, data processing, data consuming, etc. And uh, technically, one compute engine enables a data platform like for the users like data engineers, data scientists, data analysts, business users, etc. So that means you need to define this lakehouse architecture so that it will be accessible to different type of users. Okay. Now this lakehouse architecture is based on this decoupled storage and compute layers. So this decoupled storage layer has some benefits. For example, compute capacity can be independently scaled up without interfering your storage capacity. So we know that in the lakehouse architecture we have a data storage component and there is our compute component. So it can be independently scaled up. Like if you are increasing your compute engine power, you don't need to touch your storage capacity power. Okay. Now storage data and the compute engine can be accessed across the regions. So there is no need to place everything in the same region. Okay, so it can be accessible for across all the regions. So you don't need to put everything in the same region. Mostly it's happening in our cloud server, definitely. And it has an unified data processing method for this both batch and real time workloads. Okay, also you can utilize this partitioning, clustering. There is a concept of z order optimization techniques in a lakehouse storage layer. So this technique allow your compute engine to enhance this performance, okay, by skipping very unnecessary partitions. So how it's enhancing our performance? Partitioning, clustering, and Z order optimization techniques in our lakehouse storage layer. Okay, there could be many more options. Another option is like this lakehouse compute engine enhances your advanced analytics and business intelligence performance, which offering improved analytics, reporting, and AI ML capabilities. Already we talked about this type of features in our previous videos. Okay, there could be many benefits, but these are all some high level of benefits. Okay. Now, what exactly these compute engines are doing? Like, what are the activities? Now, in a lake house, a compute engine is primarily responsible for your data engineering stuffs and data consuming activities. So, within the data engineering activities, what you have? Data ingestion and data processing, and data consumption activities, what you have? Your business intelligence related activities, ad hoc analysis, MIML activities, then sharing the information with the downstream application. Okay, so lake house architecture offers you a flexibility by using various compute engines that users can utilize to accomplish their task according to their requirements. Okay, so there are different type of features we have. Now, what type of compute engines are available in the market? So we know there are three main cloud providers we have. AWS, Azure, and Google Cloud Provider. So in AWS, normally we are using AWS Glue, Amazon EMR, Amazon Athena, Amazon Redshift. Also, in Azure, we have this Azure Data Factory, Azure HD Insight, Synapses Analytics. In Google Cloud Provider, we are using Dataproc, BigQuery, etc. But there are some third-party platforms are easily they are also in the market. So many organizations use these third-party platforms for their multi-cloud support system and simplifying the data platform management. So some platforms like the Databricks, Snowflakes, also Dremio, Anna, Starburst. Okay, so these are all very new platform. You can Google it about this product. Also, there is a concept open source tool. So above all the services, there are various open source compute engines famous in the market. Okay, that cloud services and the third party platforms are adopting these open source technologies to build their own commercial version. Okay, so in terms of data engineering activities, Spark is the most popular framework. I'm sure you have heard about this name. Okay, Flink is another option for implementing this data streaming process. Market. Spark is for data engineering process. Flink is famous for data streaming process. Okay. Presto, Trino are also accepted to perform fast data consuming activities. Okay. I'm not going in detail, but I'm giving you some idea. Okay. If you heard this name, you can Google it very well. You can find out all the information in detail. Now, here is the crucial part. When you're selecting a compute engine, what are the factors you should be considered? Okay. So there are many things. First of all, does it support the open table format? Will it have the required features or version which you need? Does it integrate with other services within a cloud system? Is this compute engine useful for all type of users on this cloud platform? Okay, then whether it offers your advanced analytics option or BI features, can it work seamlessly with batch and real-time data processing? So, as well as the cost is one of the most important factors to consider. So, based on your requirement and budget, obviously you need to determine the cost, because if you go for a commercial cloud product, whenever you are taking a many as much as product, your cost will be increased. So, you have to define it like which product you really need. Okay, you need to map with your requirement before going through any further decision. Okay, and obviously if you get the option to do some POC work, like the software evaluation type of things or proof of concept, so definitely I would suggest to go for that one. Okay, so from this video you got some idea what exactly the compute engine is useful for our lakehouse architecture, what are all the compute engine activities we can do. Okay, and what kind of compute engines are available in our market, whether it's a cloud service provider or a third party provider or any open source technologies. So, and what are the design consideration or key points you need to think about whenever you will choose some compute engine for your lakehouse architecture. Okay, so from this video I feel you got some idea about this. If you like this video, please subscribe to my channel, like and comment, and please share with your friend and colleague. Thank you. Thanks for watching.